Hi, welcome to section 11.5 notes on volume of pyramids and cones. So in the last section, we talked about the volume of prisms and cylinders. And so now we're just going further with these other figures. The formulas are different, but again, the letters within the formulas mean the same thing. So yeah, the section shouldn't be too bad. All right, theorem 11.8, volume of a pyramid, just says the volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. So again, same formula as the prism, the capital B times H, except for the 1/3 is in front. And that's kind of why it comes up to a point, is where the 1/3 comes into play. So on example 1, it says, what is the volume of a square pyramid to the nearest whole number? And so again, same formula we just mentioned. We've got the volume equals 1/3 times area of the base times height. And in this case, again, if we want to find the area of the base and they just told us the base is a square, then I know that, the base is a square with all the sides congruent, and it's 35.4 meters on each side of that base. So if I want to find the area of that square, then I can go 35.4 times 35.4, or 35.4 squared, and that will give me 1,253.16. All right, so that is my area of my base. So I can plug that into the formula. Don't forget about the 1/3. And then the height I can see is the right angle distance between the vertex and the base. And so that I can see in the picture is 21.64. And so now when I put this in my calculator, it says to the nearest whole number, then you can do 1,253.16 times 21.64 equals, and then divide all of that by 3. And you get 9,039.5 meters cubed. Okay, one thing that sometimes people will do is they'll think, oh, 1/3 is about 0.3, and then they'll just do 0.3 times all of that. And it really throws off your answer a lot more than you think. So do not just use 0.3. I guess if you really wanted to, you could type in 0.3333333, and then go from there, and it should work out okay. But probably your best bet is just to multiply the numbers on the numerator and then divide by 3 to make sure you're keeping the answer accurate. All right, next up is example 2. It says, what is the height and volume of the square pyramids, the nearest whole number? And again, if I go ahead and write my formula down, I realize that I can go ahead and find my area of my base. And again, the area of the base, it is a square pyramid. So again, we're doing 40 times 40 to get 1,600. So I can plug that in for the area the base. And now for the height is the right angle distance from the top of the pyramid vertex down to the base. And I can see I don't know the height. They're showing me this is just h. So I can actually use the Pythagorean theorem to find that. You can see there's a right triangle here, kind of in the, that's not a very good hypotenuse, in the middle. And I'm looking for the height. I can see my right angle. I can see the hypotenuse across the right angle is 25. And even though it's not showing me this length from the center out to the edge, I know that if it's 40 from here to here, that it has to be 20 from here to here. So I can use the Pythagorean theorem. So I can say h squared plus 20 squared is equal to 25 squared. And from there, I get h squared is equal to 225. And if I take the square root of both sides, I get h equals 15. So that is my height. I can plug that in for the height here. And If I go ahead and multiply 1,600 times 15 equals divided by 3, I get 8,000 feet cubed. And there we go. All right, if you look down at the bottom of this page, it's kind of showing you, again, where these formulas of the formula of the cone comes from. It's showing you that if you have a cylinder and you have 3 cones that have the same shape base, the same radius of that circle base, and you fill up 3 cones that has the same height as the cylinder and same radius or diameter as the cylinder, then it would take 3 of those cones to fill up the cylinder. So that's where the 1/3 comes into play. Again, technically for a cone, it's 1/3 area of the base times height. But again, since the base is always a circle, that's why this pi r squared is plugged in for the area of the base to make it more specific for a cone. And then also it is H instead of L, or slant height. So remember, the slant height is the slanted part here of the cone. So if they give you the slant height, you'll have to use Pythagorean theorem to find the height. But if they give you the height, that's what you're plugging in the formula. All right, so examples 3 through 6. It says find the exact volumes of the following cones, leave in terms of pi. So again, the formula we just mentioned is the 1/3 pi r squared h. So the radius we can see is 1. We need to square that, and the right angle distance, the height is 3. So in that case, 1 squared is 1, 1 times 3 is 3, and 3 divided by 3 gives me 1. There is the pi there. We're leaving it in terms of pi, and then the centimeters cubed for my units. Again, the 1 and from the pi is not necessary, but you can put it if you want. All right, on number 4, the diameter is 30 feet and the height is 25 feet. So again, same formula, 1/3 pi r squared h. And in this case, the radius, you can see if this dotted line goes all the way across, that's the diameter. So half that is the radius, which is 15. We can square that. And then the height is the right angle distance, and that is 25. So in this case, we get 1,875, and then pi, and then feet cubed. All right, so that is number 4. And again, the direction said leave it in terms of pi, so that's why we're doing that. On number 5, it's same formula. The figures look a little different, but again, same idea here. So we got our 1/3. Doesn't look very good. Pi, radius we can see is 6. We're squaring that. And we can see that height, again, the right angle distance from the vertex down to the base is 12. If you go ahead and multiply 6 squared, which is 36, times 12 equals, divide that by 3. Then on number 5, you get 144 pi inches cubed. All right. And then on number 6, and keep in mind on some of the cone problems, you could have to use the Pythagorean theorem. There weren't any like that here, but that could be necessary. All right, on number 6, they're giving you the volume and they're asking you to find the radius. So in this case, if that is the case, you are going to write down the formula you're using. Since it's a cone, we've got 1/3 pi r squared times the height. And you're going to plug in what you know and solve for the thing that you don't know. So we know the volume is 24 pi. The radius is what we're looking for. And the height is 4, that right angle distance. So in this case, we basically are just trying to get r by itself. We're trying to get everything else to the other side. So in this case, if I go ahead and multiply both sides, let's see, let me kind of simplify this down a little bit. I have the 4 and the 1/3. So 1/3 times 4 gives me 4/3. pi r squared. Just kind of combining those a little bit together. And I'm trying to get r by itself. So one thing I can start with is multiply by the reciprocal of 4/3, which is 3/4. But whatever I do to one side, I need to do to the other side. And when I do that, then if I want to put a 1 under the 24, I can. So if I multiply 3 times 24 equals and divide that by 4, then I get 18 pi. And that's equal to pi r squared. Okay. From there, again, we're trying to solve for r. So we can divide by pi on both sides. And in doing that, we get r squared is equal to 18. And then if we take the square root of each side, we end up with square root of 9 times 2, which gives us 3 square root of 2. Once you get that simplified down. Okay, there's not units on that one, so just our radius would be 3 square root of 2 simplified all the way down. Okay, so again, that's it for section 11.5. Again, sometimes you'll have to use Pythagorean theorem, sometimes you won't. Keep in mind, sometimes the base of a pyramid could be any shaped polygon. It could be a triangle, a square, a rectangle, a hexagon, octagon. So that's where there can be some variation in terms of the area of the base. And just make sure for volume that you're using the height in both of these formulas, not the slant height like we used in the surface area. All right, let me know if you have any questions.